So I'd like to present Denis Barbier, who will be talking about Newlife and locale.
Thank you. Thanks for coming. So I will first talk about POSIX locales as they were defined in GLibc 2.0, then talk about a new format introduced in ISO technical report, and explain in more details collation, which is very, very important and very difficult to understand first. So, here are some links to POSIX local specification. You first have the specifications, which are very interesting. And there is a link to the technical report. You should also have a look at Peter's pages about GNU libc locales. It has many useful links. And this presentation with all sample files I present are on a page on people.debian.org, so you can download them. POSIX local specifications contain definitions for 6 categories. The first one is LC collate, which defines collation order, which means how strings are ordered according to cultural convention. The second one is LCC type, which characters are digits and letters and so on, and also it contains mappings between lowercase and uppercase characters. Next one is LC message, which is used by getText to output messages, and also for interactive answers like yes, no questions. Next, LC monetary is about formatting monetary amounts. LC numeric is for non-monetary amounts, and eventually LC time is for date and time format. A local data file is a text file which can be edited by hand. It's very easy to read, as you will see. It can contain one or more several local categories. Each category can either have a copy keyword, which means that definitions will be copied from another locale, or she can have a set of keywords and values pairs. You can have comments and continuation character, so that long lines can be split. Specification says that characters should be encoded with symbolic names within angle brackets, and also that they may be used themselves or with a numeral representation, but this is a very bad idea because you then have encoding problem. One should always use symbolic names. Strings are when there are several characters, so you have to use double quotes. Everything is pretty simple, as you can see. And when a keyword has as values a list of, can contain several values, it is always a semicolon separated list. So this is very easy. And a locale file looks like this. First, at the very top of the document, you can define an escape character and a command character. By default, escape character is a backslash. And in all locales, GLibc developers prefer to have a slash. And by default, command characters is a hash sign. And again, they always use a % sign. So I took an excerpt from the Finnish locale, and there is a command, and categories begin with the name of the category and finish with and the name of the category. And between these markers, you have keywords and definitions. So here there is an example for abbreviated day. So you see symbolic names, which is very readable because these are ASCII letters. But in order to map these ASCII letters to characters, one has to use so-called repertoire maps. So there was a line, repertoire map, to say in which file symbolic names were defined. And the format of the file is at the bottom. It was very simple. You have the symbolic name, then the Unicode value, and then a command. It's very simple. This format is very well supported by applications, but it has many weaknesses. The first one is that it cannot be extended. You can have either a copy keyword or a set of keywords. You cannot extend locales, which is very, very annoying. And repertoire maps became obsolete with the Unicode repertoire, so it does not make sense anymore to have repertoire maps. And it also could cause problem if you use different repertoire maps which may define the same symbol. So it was a pretty bad idea. And there was no transliteration, and some people want to add new locales, new locale categories. So in order to improve POSIX locales, a working group was created to try to have a new standard. They drafted an ISO standard 14652, which is called Specification Method for Cultural Conventions. But in fact, this draft has some controversial issues, and so several people did not want to have this draft as an ISO standard. And this group was disbanded in 2004. But this doesn't mean that everything is over. A new group will continue to improve this new locale, and so this is not a dead beast. And at the same time, they released it as an ISO technical report, so that people can have, in order to have a larger audience. One main difference with this new format as implemented in GNU libc 2.1 is that they no more use repertoire maps, always Unicode code points. So as you can see, this is much less readable, at least for me. It can say for you, but it's really annoying, but it is much more robust. There was also some interesting additions, like the use of ellipses. For instance, you can define digits with ellipses. It's very simple, and addition of process elevation and new categories. They added 6 categories. I will here present only 2: LC identification and LC paper, because I do not really see how to use the other ones. I'm not sure if they are so useful. So LC identification is to tell which version of to which document category definitions are conforming to, and LC paper is about paper format. So this new standard was designed to really improve POSIX locales. The problem is that it is based on, it has no ground, it is only theoretical, and there is no implementation. So several people complain that some definitions do not make sense and do not want to implement them. They sent to GNU libc developers a draft in around 1997, and GNU libc developers implemented most of this draft, and the technical report has some very minor changes. But GNU libc developers told also that they didn't want to blindly follow this standard because of these issues. So in fact, sometimes the only way to really know what GNU libc expects is to read the source code. It's also one of the reasons why I wanted to give a talk, because it's not always very easy. So if I come back to a local data file, so we now have the exact same beginning. You define escape character and command character. It's important to tell to GNU libc developers which character sets are supported. UTF-8, yes?
I'd just like to point out that this standard was superseded in the 90s with SFS 4900, which mandates Latin 15 as the new encoding, and at the same time recommends strongly migration to UTF-8.
So UTF-8 is implicit, you don't have to mention it, but if your locale have further encodings, you should tell GNU libc developers so that they can support it, otherwise they do not know. LT identification, an important keyword is the category keyword. As I said before, you should tell which categories to which specification this category is for. The problem is that there are no standardized values. So I was told that the following values can be used: POSIX 1993 to refer to POSIX specifications, or I18N to refer either to the draft implemented in GNU libc 2.1 or to the technical report. The problem is that this field is minor in GNU local dev. For instance, the Finnish locale. So at the beginning, you have some keywords which are very well explained in the standard, in the technical report. So I do not repeat it here. And as you can see, category is wrong. It should be something. It should be in fact A18N or any other. But almost all locales have this field wrong. LCC type. It contains definitions for what characters are, letters, digits, and so on. So there are predefined classes and also mappings. This one should be automatically generated from a Unicode table, so there is no need to modify them. But for certain locales, it may make sense to define some new classes or new mappings. And POSIX and ISO technical report have different keywords for both car class in POSIX and class in ISO technical report, and DebConf and map. And GNU libc supports both. LCC type also contains the definitions for consideration. So a simple example, I18N is compiled by many locales. So it contains basic definitions. The predefined classes are defined with their name and the list of characters. So it's very simple, and you can see here how commands and trailing slashes are used to split long lines. To upper is a mapping between lowercase and uppercase letters. Another example is Japanese, because they have to define new classes. So currently, they use the syntax, the POSIX syntax. So they define classes. They first define classes with car class, and after, for each class, they give a list of characters, and similar to mappings. They could be the new syntax, which, in my opinion, is more compact and more readable, which could look like this. But anyway. Transliteration is inserted between transit start and transit end keywords. It's pretty easy. You can either include predefined transliterations. There are many predefined transliterations. And there are two fields here, because the first one refers to a file, and the second one refers to a repertoire map. It is now obsolete, so it is always empty. To define transliteration, for instance, like in Danish, you put first the character which needs to be transliterated, and after then a list of strings which can represent this character. And GNU libc will display the first string which contains all the given characters in the current encoding. LC numeric is pretty simple. I will only discuss the grouping keyword, which is used to group numbers. So in most European countries, we have a grouping of by groups of 3, but it depends. Not all locales have this setting. So the grouping keyword contains a list of groups. The first group is for the digits which are to the left of the decimal separator. And then all other groups are for digits from right to the left. There is one special value, which is -1, to tell that there is no more grouping. And if this value is not the last value of the field, the last value is repeated for all other fields. The only use I know of for this grouping is a GNU libc extension. They have a percent quote printf extension, for instance, to have a float value. You can write printf percent quote f, and you will then see grouping. Finnish was not very interesting, so I chose Tamil in India, and so LC numeric defines the character used, or the string used for decimal separator and for thousands separator, and the keyword grouping. Here they have 3 and 2 values, 3 and 2. So this means that the first group before the decimal separator has 3 digits, and all others have 2. LC monitoring has many keywords, but I will focus only on 3 of them, which are pretty interesting. You have CS preset, so here CS means the currency symbol, and X here means either P or N to distinguish between positive and negative amounts. But you can have a list of values to tell if your currency symbols, presets or success amounts, if they need to be separated by space, if where to write the sign string, and so on. It's very you can write any format you want with that. I put here all the other keywords. So you have currency symbol, which is euro in Finland. International currency symbol is international currency code in 3 letters followed by a space. grouping and other monetary grouping is similar to numeric grouping. And the three fields I was referring to have some strange value in Finnish, because they say that the currency symbol does not precede amount, so it comes after. They say that the sign comes before the amount, and that there is a space between sign and currency symbol if they are adjacent. The problem is that with these settings, they can never be adjacent. So there is something wrong in this locale. I do not know why, because I'm not Finnish, but it could be fixed. Here I use PHP to show examples, because it was the simplest example, but you can use what you want. So with these settings, %n means that you want a currency symbol, and %e international currency symbol. They are different, as you can see. In one case there is a euro sign, and in the other case this is with euro in letters. And for instance, Latvian have other settings, and so you can see that output is very different. So you can define whatever you want to fit your local use. It should be noted also that all keywords can be preceded by can have a prefix int underscore to mean that this refers to the %e set format. And this was introduced because Finnish officials told the working group that in Finnish the euro symbol should come after currency symbol, but when written in letter it should come before. So this is why it was introduced, but it has not been implemented this way by the Finnish local writers, so I don't know what to do. And you can see that you can, for the same locale, you can have a different output with %n and %i. LC time, yes, Peter.
It is worth noting that the formatting of international currency symbols were broken a few years ago and fixed. So that might be the explanation why the Finnish locale was incorrect now, because we fixed the implementation so you could actually get it to behave the way it was specified. And a lot of locales try to get them right by just modifying the values until it looks right. But they're actually using the specification to write them correctly.
Okay, I didn't know. LC timing is maybe the most controversial, because for instance, in POSIX specification, when the day of the week are translated in POSIX, the first day is Sunday, whereas in the technical report they say that the translation is for the first day of the week according to the locale, which is pretty much different. And so they introduced several other keywords to tell which day is the first day of the week. The problem is that GNU libc developers disagree with this approach. I believe, I'm not sure, but I believe that they disagree. So we still have the POSIX behavior, but the new keywords are not supported really, but they are understood. And for instance, in French, so we have AB day for abbreviation of day, day of the week, month, etc. And more interesting, you can define date and time format. There are 5 fields. DT, FMT is to display date date with date and time, as written by date plus %c. So there is an example below. And DFMT is when date is alone. So this one looked pretty good in French. And you have also format to display time of the day. In France, we do not use AM and PM notation, so these fields are empty. And the last field was requested by Corvutill's maintainer, so that translators have a chance to have a localized output of the date command when it has no arguments. And the problem is that when it was added, POSIX local was copied into all of the locales, and in French it looks really wrong, and it is also true for almost any locale. So this can be fixed, and you can use this these notations, but I don't have time to extend about that. Next section is about LC messages. It is used by getText, but also to answer simple yes/no question. And you have two fields, yes and no expression, which are regular extended regular expressions. And we can notice that almost all locales have a trailing dot wildcard, which is pretty useless because these are regular expressions and does nothing. LC paper is to define height and width of paper, mostly used in for this locale. Units are in millimeters. So, if you read specifications and this slide, you are able to modify things if they are broken for your locale. This can be easily done. You do not have to mess up with your settings. You can export the log path environment variable, and glibc will then search local data in this directory. So you copy your locale into a working directory, you edit it, you run local dev to have to compile a local data, and you can then play with this data to see how to fix things. So I will now talk about collation, which is, in my opinion, very important because it's pretty cryptic at first, but in fact it is very simple. So anyone can have a look if your language has some strange settings, or it can be easily changed. The reference for this is ISO 14651, written by Alain Labonté, about international string ordering. He describes the algorithm which will be explained here. Unicode also has a working group, and they have algorithms which are pretty similar to the one described by Alain Labonté, but with small variants. And mostly they use different notations, but it is very similar. And there is also a nice presentation by Mr. Chilton about Tibetan script. It's nice because first the Tibetan script is pretty cute to read, not to read, to look at, because I can't read, of course. And it is very very simple. So the key point of both Unicode and Alain Aponte algorithms is to replace sequences of characters by other characters so that the usual string comp can give the expected result. I will explain just now what does this mean. For instance, if you only consider ASCII letters, you assign 1 to letter A and so on until Z. To compare cow and cat, you see that with these numerical values you can compare the strings. This is pretty simple, but of course that we use many other characters. For instance, the first problem is how to sort lowercase and uppercase characters. In the POSIX locale, you have first all uppercase characters and then all lowercase characters. But in EU and US, for instance, words are sorted like in dictionary, which means that there is no distinction between uppercase and lowercase characters. So this needs to be refined. The first solution proposed here to interleave uppercase and lowercase characters does not work, and the idea is to add other levels. So we keep the same level 1 code, which means that lowercase and uppercase A have the same level 1 weight. These values assigned to levels are called weights when about collation. And you assign a weight value of 1 to lowercase character and of 2 to uppercase characters. And when this is done, you concatenate all level 1 weights and then afterwards all level 2 weights. So here, if you want to know how cars and cat written with mixed uppercase and lowercase characters are sorted, glibc will perform they will put all weights together in this array and run strcompa on these two arrays to know how these strings compare to each other. But in fact, this example is broken. It does not work like this. For instance, if you try to compare char and chara, the one there is the weight one. There is a problem because you mix level 1 and level 2 weights. So something needs to be done. There are mainly two solutions. You can either decide that all weights for level 1 are greater than any weight of level 2. If I remember, this is what Unicode does, but I'm not sure. And another possibility is to add a safeguard value, which is lower than any other weights. This is what is done by glibc. Obviously, 0 is not a good value because string comp will choke on it, and so 1 has been chosen. So all of their weights have been shifted by 1, and now lowercase level 2 weight is 2 and uppercase is 3. So if I consider the same example, the addition of this level separator ensures that everything works as expected. Now char is sorted before chara. I will give other examples, and here is a sample program to display collation weight. It is available on the website if you want to download it. I will use it in the presentation. So if I consider this sample collation definition, you have an LC collate, and it ends with end LC collate. You have to define symbols by collating symbol, and after that you assign weights to your symbols. They are assigned sequentially from 2. So they are 2, 3, 4, etc. But in fact, there is an internal optimization. glibc tries to lower weights without changing the relative order. glibc here sees that upper and lower are only used in level 2 and do not interact with others. So automatically it chooses the weights which were written before. So you can compile this locale with the local def. You have to add the -c flag because it is not complete, and local def will complain if you try to compile it. But with the -c flag, it works fine. You compile it, and you can see that the results are exactly what we had previously. So it works exactly as expected. So symbols must be defined before being used, which means that collating symbol keyword must be present, and weights are automatically assigned from 2, and there is an optimization. And now if we consider another example, we can try to work with the diacritics. And this is now this is always the same idea. You define symbols for your accents, and you combine accents and symbols, and it will work as expected. So here in this example, I choose to assign the weight of 2 to characters which have no diacritics, 3 to dialysis accent, and 4 to acute accent. And if I run this sample with French words which are côte côté, it's a well-known example. You can see that they are sorted this way by this locale. The problem is that in French we have a very strange convention, which is that when strings are quasi-homographs, which means that if you do not consider diacritics, they have the same letters, then accents are compared from right to left, which means that we will first have A without accent, and then A with accent. And this is easily performed in Newlife if you replace the order start keyword on the right. You have here forward, and you replace it by forward backward, which means that on level 2 only, you want to have a backward direction. And now we have the right collation weights, which means that this locale can sort these letters according to French rules. So how many levels do you want? At least 3. So base characters, case, and diacritics. But we need another one because we need to make distinctions between all other symbols which are not letters, like punctuation marks and so on. So in fact, almost all locales use 4 levels, but this is not a rule. you can define as many levels as you want. So here is a typical example with 4 levels. You first define your symbol with the collating symbol, then you tell their relative order, and locale left will assign values to them automatically. And after that, you for each character you want to represent, you tell which weight should be assigned. It's very, very simple. And it is even more powerful than that, because in some languages you can combine characters. For instance, in German, the S ligature is sorted like SS. And on the other hand, in traditional Spanish, CH is considered a letter between C and D. So we have to here is an example. The S set German ligature, you only have to say for the SZ character you assign the weights of the characters you want to represent. And so as you can see, in the 2 first rows, the DAS and DAS have the same level 1 weights. So they will have no difference at level 1. Only other level have a difference. Similar to A and E ligature. In Norwegian Bokmål, AE ligature is a letter, so some locale can have other definition. The other case, many-to-one mapping, one could believe that it would be quite natural to have this definition, but in fact this does not work this way. You have to define a collating element and use with the given symbols, and after that assign weights to it. Okay. You can see all the examples, and by combining both, you can have many mappings. The problem is that local left has some bugs, and sometimes we will discover that it does not work exactly as you want, and it's really annoying. ISO 14651 had a tailoring. They wanted to ease writing locales, so they proposed a scheme which you can see here. You copy a table and you only modify the characters you want. So you have you can reorder weights to change relative values, and it's very simple. So my conclusion: to modify locales is very easy when you have some tutorial, and I would like that everybody helps in fixing locales bugs. The problem is that with this notation, it cannot be written by hand. So we need some tools to work with these local files. These tools does not really exist.
It does.
I also have some tools, but in my opinion, it is not usable by everyone. This is the problem. But maybe, I don't know. And eventually, if you have problems, please ask on the libc locales mailing list. You will be very welcome. I also have a final slide. If there are developers who want to play with local def. And there were some open issues I wanted to investigate, but okay, it's not very important. Maybe if you have questions, it would be more interesting. Just about Estonian, there is a problem because they sort the Z later between S and T. So when you write a regular expression A minus Z, it will give very strange result. So many programs are broken, and something needs to be done. It's pretty very strange. So if you have questions, yes.
More comments than a question, actually. Denis thought that there are no tools to write locales, and they are lacking. I would insist on it. They are desperately lacking. During the DI work on Debian installer, which we all run and go to the presentation we will have, I had to write locale without knowing what the hell this thing has to be written. And it is a nightmare, complete nightmare. So if there are coders who want to find a very funky project, just try to think about writing a simple tool for people who want to write locale. Because writing locale needs a deep knowledge of languages, but it shouldn't need a so deep knowledge of the Unicode table. I need to know by heart the whole Unicode table. That's crazy.
Doesn't everyone?
For this tool, it will be helpful to know what is specification for the locale format. Because there is no such specification.
Yeah, but at least to write down the simple parts about LC date and all these things which are very boring to write down, and I think that Jordi can tell also, because he was very lazy, and for writing the Catalan in France locale, he just merged together the Catalan Spanish and the French French. Okay. Because this is hard to do.
I did the Andorra, the one for Andorra too, and I had to write that one.
Yeah, for Andorra you had to sit down and write Unicode by hand. You are a hacker. Yeah.
Oh yeah. Lock him in.
Martin?
Yeah, so about that Estonian example you had,
Yes.
one question that comes to mind is that right after Woody was released, Meelis Rose filed a bug against libc, complaining that it should have been as well ISO 8859.15. Was that ever fixed in the end?
Sorry, I don't understand the question.
That for Estonian, the default encoding, let's call it the legacy encoding, should be the -15. And it
Yes.
has been for a long time -1, and
Yes, but Martin Wick says that in the first version, the Estonian locale had a Latin 1 encoding, but it is wrong. It should always have been Latin 9. But glibc maintainers refused to modify it because they have a strong policy about locale names. They never change a locale. They never change the encoding of a locale. This is why we had to switch to Euro names, because you cannot. They do not want to change the encoding of a given locale. So as they had it wrong the first time, they did not want to modify it even in this case.
And do you agree with that policy?
I have no other choice.
In some way, I agree with it, because you don't want to expect. It's all about inspections. When you use the locale, there's many more differences between the -1 and the -15 than just the euro symbols. There are many other characters, not that many, but still more than enough. Then this different behavior in these locales is important enough to give it a new name.
But getting back to the question of Estonian, I mean, it's never been -1, for instance. In fact, it should have been -4, which is what has been used in the Baltic countries until recently. And by the time Estonia joined the Free Software Universe and submitted their data for the locale, it was 15 already.
Yes, but
And that point was mentioned very clearly both by Melis Ross and by the guy at the
I see your point,
National Linguistic Institute that there's never been any standard until that one was decided.
Mm-hmm.
So that
Anyway,
was a funny incident.
I'm not a GLibc maintainer, so I can do nothing.
But I just remember that on the Debian side, the question was asked, could this be changed for Debian?
I'm not sure if this is a good idea, really.
Okay. All right.
Peter?
The approach used for changing character sets in the locale is to give it a new name. You use the same file with a new character set added to the name, and this will be the new name of the locale. So that will have to be done in Debian as well to avoid being in conflict with the settings on different all other distributions.
Any other question? Yes?
Yeah, I was looking at the Indian locales, which are there. There are actually for most of the major languages using UTF-8. But there are a number of other like legacy encodings.
This is not a problem. You mean in the local data file or?
Well, no, there are, but there are no locales for them. Like they would
all you need to do is to generate your locale with a different encoding. This is the same. You have the same. You have only one local data file because it uses Unicode, so it can represent any encoding.
Okay. Well, because I'm thinking specifically, it's called ISTI, Indian Standard Code for Information Interchange.
Yes, but
and
it is
hybrid
supported.
kind of thing. It's not like an ISO-based thing, so it doesn't map directly.
I'm surprised. I believe that it is supported,
It is?
but I'm not sure. But
Okay, it may be. It ought to be, but I didn't see anything. Of course, that's even better if it's all.
any other question?
Well, just one quick comment that might be of interest to Finns or to people interested in Finnish language. I have the graduation paper of a student in the Kuopio University that tried creating recently a local for the Karelian language.
Yes.
The Karelian language is basically the missing link between Estonian and Finnish.
Yes.
It's hardly spoken nowadays anymore, but there's still a few people in eastern Finland and along the Russian border speaking it. Very interesting paper for those who want to read it. I brought it along. He basically describes all the steps he had to take to create the local, the problems in researching what was the proper ISO code for it, then the horror of finding out that there is no ISO code for it.
Well, if you have any other questions, or you can talk to me later on here, or please ask on libc locale's mailing list.
One small comment to the programmers out there. I thought you had the comment about check Turkish and see how it doesn't really do case conversion conveniently.
Yes.
This is a common problem for quite a few programs. They expect that if you have one character and convert it to lower or uppercase, you will still have one character. This is not true. You might have 2 or 3, you have no ID, so you actually have to store them in an array.
Right. Thank you.